Hello everyone, this is Srikanth Vissarapu here, who work as a software engineer at Meta. Today I'm going to discuss about engineering scalable infrastructure. So, primarily looking at various challenges the current ecosystem of software engineering is facing, essentially the increasing complex digital landscape. Cloud spending is projected to increase by $678 billion by 2024. Platform engineering is extremely important in this context for cloud adoption and infrastructure management. So, what are the various things that are extremely important when we are talking about platform engineering evolution? So, faster deployments, obviously, we talk about all the microservice architectures, cloud deployments at scale, and stuff like that. So, eventually, developer productivity and also engineering excellence almost always depends on how fast we can deploy things into production, right? These are some of the architectural constructs that can help significantly increase faster deployment to almost like 40%, and also reduced overhead in terms of processes, manual steps, and all the operational overhead that are necessary, right? At the same time, increasing the satisfaction, obviously, developer productivity, they're able to deploy the code, run the code, release out features much faster, definitely increases the developer satisfaction significantly. Definitely, this is more incremental gains across the stack, an amazing opportunity to transform any development organization into the evolving landscape of cloud deployments. And let's talk more about what is this platform approach, first approach. So, what does it actually mean? Again, looking at the current challenge, right? There is definitely a lot of gap between what developers need to build and what they need to know to build it. So, essentially, more what they want to build and obviously what they need to build it. Essentially, right? So, traditionally, DevOps models often burden developers with infrastructure concerns like creating cognitive overloads and slow innovation, right? So, what are we trying to achieve? Self-service infrastructure. Engineers or developers should be able to provision their resources, VMs, run their workloads at scale, manage configurations, mostly self-service, without even going through the complex processes of ticketing systems or various other things. But obviously, reducing a lot of that toil in terms of whatever is necessary. How do we make that more self-service model? And obviously, some kind of a golden path, predefined, optimized pathways, guide through common scenarios, that can help with all the best practices. How do we develop a code? How do we get the infrastructure necessary to develop, deploy, test all the different constructs of software development? Central governments, and also obviously one extremely important aspect of it is like the more freedom we have, it's also extremely important that we have that enough controls, checks in place. It's more defensive mechanism. Obviously, we want to make sure least on security principle, and obviously whoever needs to have the access, they can have the access, but obviously we need to make sure that there is a balance between giving more flexibility at the same time, also making sure that security, privacy, complex things are also in are also in place. So let's talk about architectural patterns for multi-cloud success. Again, the most important thing is that a lot of companies are evolving into not a single cloud environment. So now obviously every cloud has its own positives and negatives. So primarily, eventually a lot of companies are evolving into using this multi-cloud architecture. So looking at various architectural patterns that are used currently in the industry, one typical pattern that we usually see is like hub and spoke model. Essentially more like a central platform hub manages core services like authorization and monitoring, governance, all these foundational components that are necessary for building any strong software stack. It's like it becomes a common hub, and obviously you build services on top of it. And the next important thing is once you build all the services, what is necessary for them to communicate? So it's like there is various common constructs, various platforms that are already built with the service integrations like STO and various other things. Essentially, when you go into the multi-services or microservices kind of environments, all these things will become extremely important. The developers doesn't have to really think about how does the orchestration between the systems are happening. Obviously, all these existing tools will really help accelerate the development a lot. One of that is like providing that consistent networking, inter-service communication, service meshes like STO and all that in Kubernetes kind of environment are extremely useful and important. And the other important thing is our policy as a code frameworks, essentially more like governance rules are actually codified and obviously more automatically enforced. Compliance without a manual interaction, which makes it much more easier to run systems. And these are again a very high level of constructs of what are the important architectural patterns that I have seen are extremely important in any cloud environments. Let's talk about how do we optimize developer experience. in a world where development is changing, how we code is changing pretty significantly. It's extremely important to give the freedom for the developers to build at scale faster, and all those good things about how can they test it, deploy it at scale. Providing all this frameworks is extremely important. There's a few things I would touch upon the similar aspect of it as most importantly intelligent code scalability. AI tools. If you look at right now, it's all a lot of Gen AI tools are extremely useful across the industry like something like we have a GitHub Copilot. It's like a lot of similar things where all the other LLMs also have similar tools as well. So these are proven to be extremely useful in building some kind of a boilerplate code. It is like building some test cases for whatever code we have written, obviously helping provide custom insights. How do we fix the code with any bugs, and things are evolving and also providing a lot. But these tools are getting much better as well. As they get better, the user developer productivity is also significantly increasing a lot. And the next important thing is like CI/CD models. We need to have a strong CI/CD system. Again, what does a CI/CD mean? No automatic testing pipelines. Whenever developer pushes a code, a strong enforcement of testing all the core components as unit tests, and obviously we have some kind of integration tests as the code deployment as well. So having that necessary checks and balances would really improve developer experience on one aspect of it. At the same time, we have right checks to make sure that quality code is getting into production. And other important aspects, self-healing infrastructure. Things can go wrong all the time, right? So I think how can we build our system such a way that when something really goes bad, it can self-heal. It can be as simple as saying the new build that is deployed into production, we have some kind of canary kind of a deployments, right? In that case, if some new build doesn't work really well, it self-heals and also goes back to the previously healthy build. So that's one example of how can we build infrastructure or deployment pipelines which can really improve the developer experience. At the same time, we have that stable software start running in production without any interruption at any point of time. These are few things I want to touch upon to see how can we build strong developer confidence. Now, reduce a lot of unnecessary toil of the developer. The best thing they are good at is like building code. So obviously providing that opportunity to build strong code and also giving all the tools and infrastructure to accelerate that and support that is the best thing that we can provide in any cloud environment. So that's one few things I want to touch upon in this aspect. The next thing is infrastructure and cloud scale. So essentially we are taking care of the developer experience. They are able to build the code, deploy the code, test the codes. Then the extremely important aspect of it is like now we need to also look at where it gets deployed. So basically you are trying to deploy things essentially, right? So it gets into some VM, some kind of a Kubernetes environment or various other constructs, like a microservice in a cloud kind of environment. So in that case, the most important thing is like that now we are dealing with all the hardware of it, like all the VMs and how do we deploy as a microservice, whether it is like a Docker containers or all that in the construct of Kubernetes. So we have something like small pods and stuff like that. So how do we package them? How do you deploy them? These are extremely important constructs when you go into this at scale deployment. So building that, there are a few things I want to touch upon in the same aspect. Like when we are building this infrastructure, it's called a few things like moderate template libraries. So this is more when we want to build reusable components. Again, it's more, there are various constructs to it. So basically, auto scaling the infrastructure is one part of it. If we are exceeding some limits of the infrastructure, obviously we can have some kind of template which can kick in and expand our service. For example, there are some constructs and our workloads are not more than what we have currently purchased from cloud, and we can have those controls and checks to essentially expand our infrastructure in a way that we have more compute available to run our workloads. Similarly, GitOps workflows is an extremely important tool as well. Again, the same thing, providing audit trails of what has went in, what is rolled back, and all those other good things there. Again, the other important thing is after we have provided all these scale components, again, extremely important thing is we have to look at the complex scaling as well. So just making sure that whatever libraries that we're building as part of the infrastructure deployment they're all security tested. There's like a lot of other tools that can help us build, even for the as simple as Docker containers or what the Kubernetes environment. We can have some kind of automatic tools that can scan the containers and make sure that none of the libraries that are built and has some known vulnerabilities, and make sure that these are compliant and secure before they are put in production. So that is one aspect of it which are extremely important in a way. And once we touched upon first we talked about developer, how can we make him agile and make him faster and stuff like that, and talked about what are the constructs of infrastructure, how can we build an infrastructure which is robust and compliant and all this good stuff. Now, once we have all those important things sorted out, next important thing is like, how do we measure what we built is successful, right? So there are various metrics that that we can look at as technical metrics, obviously. So I think from the technical aspect of it, how fast are we deploying, right? The mean and lead time of the change. So now mean time to recover. If things go bad, how fast we can recover from it. And all key insights, like, what are the failure rates looking like. So these are all like very good or important technical metrics that would eventually provide us insights into how fast we are deploying code, how fast we are reacting to change, how fast we are able to roll back and make sure there is less downtime to the customers, right? So extremely important aspects of it. And the other important thing we need to think about is like business metrics. Now we look at the technical construct of it, then we need to look at the business aspect of it. So how much we are spending, or what is the cost for deployments, realization rates, and how much time it is taking for us to go to market. Now, for example, traditionally in the past, when there is less or no cloud in a way, it's like a lot of companies used to build their own data centers. Scaling the infrastructure is a relatively difficult aspect of it, because hardware has to be procured from somewhere and also provisioned, and all those other good things have to happen. So before we can start utilizing it for anything, right? In that aspect, I think. But if you look at in the cloud, how fast or how agile we can adapt to new changes. Like, for example, I have to deploy a new feature, or a new product, for example, where how fast we can get it to market. And obviously, think about an aspect where I need to release a product in some other country, right? It becomes extremely easy, or I don't have to buy hardware from a different country, or whatever is a good thing there, right? So I think it becomes extremely easy for us to think about those kind of things. How are we progressing? How easy it is? Some of those metrics are extremely important as well. Other thing is developer satisfaction. Now we have built this robot system. How do we know the developers are really enjoying it, or it's becoming really a painful work experience? So obviously, some of the things that we could do is look at the surveys, get the feedback, try to see what are the pain points, and improve on it. Right? So obviously, I think we have to improve our product. And obviously, we know on a high level construct what are the good things that these systems, like our cloud systems, can bring in. And every system is different, and we have to adapt to the surveys and feedbacks and make it better or better time. And now let's touch upon some important aspects of what are the emerging trends in this cloud infrastructure, right? Platform engineering. There are a few things I want to touch upon here. One is like AI-powered operations, right? Machine learning models. Now AI is everywhere. I think AI is disrupting a lot of industries. I think this is also an extremely important industry, in my opinion, where AI can play a big role. AI can be able to predict resources based on existing which and other constructs of it, can really predict what are the needs of the future, optimize cost, provide insights, provide suggestions. How do we improve our cost, deploy models? And I feel like there is a strong importance that AI can bring into this cloud platform engineering stuff, where it can improve significantly, in my opinion. Another important aspect is a zero trust. Security should be essential part of the cloud platforms. It's extremely important that security becomes the number one or important thing while we are building this microservices framework in more like a cloud environment. And one of the important concept is zero trust. We start with something, considering that people have next important thing, edge computing support platforms right now. This is again running on the edge, right? So more like IoT and real-time skills. I think this is all picking up really well. I think in terms of increasing compute speeds and providing that vision, and also providing that capability to run it with increased networks and all that. I think IoT real-time processing also has a significant opportunity here. And now let's talk about how do we implement these strategies, right? Obviously, we can't really go from A to B directly, and there has to be some kind of evolution here. So in my opinion, we start with a phased approach. We start with pilot teams. We start with some small teams, test out, build the base infrastructure, and allow teams to adapt to this new framework. Whether it is a microservices framework or if we are building Kubernetes platform, have some opportunity to build some base core constructs. For example, we can have something like how do we deploy things. There is like various things you can do. Like you can do some kind of canary deployments, blue-grey deployments, some construct that you can build into the platform. The next thing is like, what is a consistent way for the software teams to build their packages and deploy them into the So for example, if you take Kubernetes service, use a Kubernetes environment. This is again providing that opportunity is also having that base layer of platform built that let teams adopt this framework and provide that opportunities for engineers to also come in and contribute to it and make it better. I feel that is an eventual process. We start with few teams, pilot them, and identify what are the other things that we can make it improve, and you progress on. The next important thing is once we have enough confidence with all the pilot teams, then we start about socializing with broader teams, functional, cross-functional teams, and also thinking about how can we make it a shared ownership now. It's like this is a platform. Obviously, people can come in and contribute and improve on it, and also extend on it, and all those good things. Right? So where other teams can also extend it, and we have that big ecosystem of platform development within the company. Yeah, the next important thing is, again, as I was kept on saying, it's a continuous evolution. Things can improve, things can extend based on the feedback. We keep improving the platform, now we keep using it and improving it based on the needs. Now, next important thing I want to touch upon is, so this is a complexity gap I want to talk about. So we have operational tooling, build and deploy. If you look at this, like we have operational tooling and what developers need to know, there are knowledge and context and end-to-end responsibility. So I think this is just giving a high-level view of what is the intersection. Operational tooling, you need operational tooling for developers to build and deploy at the same time operational tooling for knowledge and conflict. Right. So if you look at this sweet spot of a cognitive load on the load on the developers, it's more like what are all the things that are extremely important. If you look at the midpoint where it kind of merges in, it becomes a collective responsibility, essentially, right? So that is an extremely sweet spot there. So now let's talk about multi-cloud governance, right? Then again, once we have a strong system fundamental foundation and building all these good things, extremely important thing, as I was mentioning before, is having that security and compliance in place as well. So two or three things which are like a lookout things we need to think about is like inconsistent security controls. So without having right policies in place, it becomes extremely difficult. Now, cost management. When we move to cloud, there could be a lot of offerings, a lot of tools, and various things that can happen. And cost is an important factor when we use these things. So having that management and cost management strategy is also very important. And obviously, other thing is also compliance. So making sure that we are based on the industry we are in, we are compliant, and having that right controls in place is also very important things that we need to think about. The next important thing is like self-service infrastructure. Why do we need self-service kind of information, right? So now, if you look at the graph on the left, is like traditional approach. Provisioning time used to take a long time. Compliance issues used to take a long time, and developer wait time. Obviously, we talked about some of the aspects of traditional approach of having our data centers. And next thing is like platform engineering. Now we are building for the cloud, right? So how can these improve is what we touched upon so far. So it's more like how can we self-service infrastructure, you can drastically or dramatically increase the provision times, and obviously provide that insights into compliance issues, and also improve the developer productivity over time. So then I want to touch upon some golden paths. How do we balance control and freedom? So when we give freedom, there are a lot of things like with freedom is a lot of responsibility. It's extremely important to have right controls in place so that all the things will run as per the security compliance guidelines, right? So having that right controls also will help with few of the things that I want to touch upon. Developers can reducing cognitive load. They can just build business logic. They don't have to really think about it. What are the infrastructure developments, accelerate development skills, and obviously they are more important in how they want to develop, right? So I think that's a good thing they are, and they are good at it, providing that opportunities. And another thing is like consistent implementation. Having that structured patterns ensure security is also very important. And flexible boundaries, right? When providing guidance is allow for customization. When there is a new requirement, obviously demand can deviate from standard patterns. So these are a few golden paths that we can provide, right? So what do we think of the future of cloud? So I strongly believe it's more than a technical evolution. I think the pace at which it is improving is significant. I would say this has transformed a lot of industries. I would say providing that agility to the developers and faster go to market and various other things. So I think the path definitely is very clear. Robust platform engineering capabilities will definitely be the future, and building those foundational components across the stack are extremely important for the success. So those are all the basic constructs I want to touch up for this talk. Thank you very much, everyone. Have a nice day.